Okay, let's do another example here. So this one is not directly out of the book, that we've just got this here. So example smiley face, which is so nice. So y is equal to the square root of x, y equals 0, x equals 4. So I'm going to find the volume bounded by these parameters and about the x-axis. So let's draw this. About the x-axis, y equals 0 and x equals 4. 1, 2, 3, 4. So I know this is 4. So I'm bounded right here. Oops, let's do that as a different color than what my axis is. So x equals 4 we've got in the square root function. Goes up here at 1, 1, right? And 4, 2 that we have. So here's my square root function. Let's call this right here at 2 because we know what's going on. And here is my region. Now here's my question to you. I am going about the x-axis because that's what my problem told me, right? Which method do we want to use? Washer disk or shell method? Yeah, everything's already in terms of x. So I would highly recommend us just going ahead with the washer method, right? And if I have this, and it's really the disk method at this point, because I'm sitting on this axis right here, this y equals 0. That's the other line that we have. It's sitting right on that axis. So if I have the washer disk method, that is pi r squared. So volume is going to be pi. And if I'm at dx, because I'm going around the x-axis, I know this means the same. So I'm going to go from 0 to 4 because my differential is dx. And I've got pi, which I threw that out front. And then my radius here is going to be that function. So this is x to the 1/2 squared. I'm going to bring that dx in here a little bit. Okay. So volume is equal to pi. And I'm going to go from 0 to 4. Power to a power, we multiply. And so I've got pi, and this is 1/2 x squared from 0 to 4. So pi here, and I've got 1/2 times 4 squared minus 0, of course. So 2 goes into 16 8 times. So I've got 8 pi. Now, just for fun, because you know it is, I'm going to take this exact same graph, because I'm so digging my technology, right? I'm going to copy that. I'm going to paste that over here again. But look at what we could do. What if here, I'm going to do smiley face again. What if we take this same square root of x, y equals 0, x equals 4, about the x-axis. And I want to do the shell method. Let's go purple. Could we? Yeah. Yeah, we could. Because if I'm going in this direction, I'm going from one function to another function. If I'm going about that x-axis, then I need to put everything else in terms of y. Let's make it happen, Captain. If I want my function here to be in terms of y, I square both sides, and I've got y squared is equal to x. And we're still going from my bottom here is now going to be my function, right? The bottom of this is now going to be my function, and my top, or the right side, is going to be 4. So if I have shells, volume now is 2 pi RH. So I've got 2 pi. And if this is in terms of y, then my interval has to be in terms of y. So from 0 to 2. My radius is y because it's dy, right? So everything has to be in terms of y. So 2 pi RH, right? So now this is going to end up saying I've got my top function here, which is 4, minus, right, the top or the right here is 4, minus that bottom, which we know here is y squared. And now I'm set and ready to go. Ooh, check it out. I am going about the exact same axis. I am looking at the exact same figure. I've got this filled in bowl. Whether I have a filled in bowl and I'm looking at my volume about the x-axis no matter what in terms of y or in terms of x, my volume better be the same because I'm literally talking about the exact same figure. It's just another method to get there. All right, so I should come up with 8 pi. Let's find out if we do. 4y minus y cubed dy. I'm going to scoot this over a little bit. So what's that is going to be, so this is going to be y squared. 4 divided by 2 is a 2, so I'm just going to go ahead and write that in there. Right, we've got this. Minus 1/4 y to the 4th from 0 to 2. If I plug that in, ooh, it's minus 0 again. I love that. 2 times 2 squared minus 1/4 times 2 to the 4th minus 0, of course. So 4 takes out 2 of those. So I end up with the purple. 2 pi times 8 minus 2 squared, which is 4. What just happened? And it should be. So your volume ends up being exactly the same because I'm talking about the same figure. If I were to change the axis I was revolving around, then that would affect my answer because those are two different figures that we have. But this is literally, I'm talking about the exact same thing. These are two separate methods to do the same thing. The shell method and the disc washer method to find the exact same thing. The big difference here, whenever I'm looking at this, is which method is going to work best. Hey, we just proved sometimes they both work. And in the previous examples, sometimes one works better than another, right? That's what you are going to have to discern. As you approach these problems, that is what you are going to have to figure out. All right, let's try some more.